Silicon, the foundation of modern technology. Every transistor placed with purpose, every watt wrestled from physics, where every instruction set earns its right to execute. This is how performance gets driven, how efficiency gets built, how intelligence acts, not just answers. Our future is with ecosystems, shaped by architecture, capable of connecting technologies, tools, and partners, powerful enough to execute, efficient enough to scale, familiar enough to build with speed. Tomorrow, it's about the progress we scale through open platforms, shared standards, and partnerships, amplifying each other's strengths. A unified architecture engineered for systems. The next chapter is being written in silicon with our engineering at its heart. Built different, built together, built on Intel.
And now, ladies and gentlemen, please give a warm welcome to the CEO of Intel, Lip-Bu Chen. 让我们用热烈的掌声欢迎 Intel 执行长陈立武。
午安，大家好。非常欢迎你们大家来参加我们这个 Intel COMPUTEX。我昨天晚上9点半就爬那个象山谷，1000那个 steps。This is the Elephant Mountain, and so 1,000 steps to 184 meters, and so I survived. And then came down with one piece, so I'm here. So, but if I walk a little bit slower, then you know I'm exhausted. But anyway, it's a beautiful view. I mean, I highly recommend all of you to do that. Yep, I think first of all, I think delighted to be here, and this is an important event, and I'd like to get started. And about nearly 6 decades ago, a group of brilliant and highly motivated engineers and venture capitalists, including Arthur Rock, Don Valentine, and many others, they found companies like Intel, Apple, and others broadly set the motion, the largest economic known to mankind, create what became known as Silicon Valley. And this is a very exciting time, and that is a very same ambition and mindset with the semiconductors make across the ocean. That sparked the creation of Silicon Island right here in Taiwan. And I have been very fortunate to associate with the creation of semiconductor industry in Taiwan 40 years ago. Because 40 years ago, Minister K.T. Lee, Li Guoding, invited me to lay the foundation of venture capital concept in Taiwan. It's a very new concept, and people put money with you, and you play the money, and then you share the profit of 20%, but you don't share 20% of the losses. So this is a very unique venture capital concept, but I managed to do that, and then with the help of Minister K.T. Lee, and then development fund, and I set up my venture fund. And about the same time, Maurice Chang from TI came back to E3, and then set up the TSMC. So it's a very exciting time that I'm being involved in this whole science park, and Hsinchu Science Park, and the foundation will become the Silicon Island. And so I really see the benefit of, from OEM, ODM, from design to manufacturing, it's all here in Taiwan. Taiwan PC ecosystem has played a critical role in Intel growth and success. In fact, last year I was here to celebrate Intel 40th anniversary in Taiwan. I want to thank all of the suppliers, partners, and customers for 40 years of partnership with Intel. As partnership continue to grow, thank you. As partnership continue to grow and stronger every year. It had been the year since I stepped in the role of Intel CEO. To be more precise, 14 months to being CEO of Intel. And it may be the first CEO can speak Mandarin. And in fact, couple of customers of Taiwan, very important partner for us, is that Lip-Bu also very unusual if a CEO can drink liquor with us. But anyway, I'm part of this community. Execution has always at the top of my list. To do so, we had to bring focus back to the core. At our heart, Intel is an engineering company. And that's what I decided from day one. I came to become CEO of Intel. I have all the engineering report to me. So the understanding to really drive the engineering, drive success in engineering performance. Our customer and partners are always already seen the shift in the Intel showed up. We are just getting started. And so stay tuned. We have a journey in front of us. Opportunity ahead is enormous. And our job is to stay focused, execute, and deliver. Every year, Intel ships hundreds and millions of SoC, orchestrating silicon across every industry, working tightly with our partners' ecosystem across each layer of the stack. From silicon to SoC to system and to software. This generates trillions of dollars in value across 4 core compute ecosystem. First, personal computers. Second, edge, agentic AI, and later physical AI. Third, foundational data centers. And finally, emerging intelligent centers that will power digital agents of the future. Each of these ecosystems represent generational opportunity. And increasingly, each of these will need purpose-built CPU, GPU, and ASIC solutions catered for specific workloads and application. The silicon we are building now will be for human use and the digital agent use. Let us begin with the ecosystem that started all. To talk more about the PC ecosystem, please join me to welcome to stage our new leaders for client compute and physical AI, Alex.
Thank you.
Thank you.
Thank you. Thank you, Lip-Bu. Little story about me. The first time I came to Taiwan was the year 1990. And I was fresh out of school, first job, first international trip, first East Asia country I've ever been to. And I came right here in Taipei. And I quickly realized, even back then, that the desire to grow, the mindset of win-win and cooperation is all over all of our customers and our partners here in Taiwan. And so it quickly became one of my favorite countries to visit and work. And now, forward the clock 36 years, I'm here in my first international trip with all the great people here at Intel. And where do I come? Right here to Taipei. Thank you. I can't wait to plan and build the future with you guys. So let's get started. We have a lot to cover. Intel has continuously increased the pace of progress across all PC segments. Workstations, desktops, creators, gamers, premium and mainstream laptops. Every major segment is driven by an Intel system solution. With that vast coverage in mind, we're adding another dimension to scale these products even more effectively. The Intel 18A process is now at full scale. We have a full lineup of products with hundreds of design wins to prove that. At CES, we launched the Core Ultra Series 3, Intel's first product built on 18A process technology. It's setting a new standard for premium mobile performance and battery life. The Ultra Series 3 enables great user experiences across any tasks with a very fast response CPU, a highly improved GPU, low power processing NPU, and the latest multimedia capabilities. It's a perfect blend of IP, performance, and power for any AI and agentic experience. It's allowing us to lead the way to transform every PC to an agentic capable platform. Today, more than 300 designs are shipping across consumer and commercial segments, over 300. And to scale these capabilities even further, we've taken the latest Core Ultra IPs and specifically tailored them for the mainstream market. The result? The Intel Core Series 3, introduced in April. Let me repeat, we just introduced this in April, and it's already scaled up to 70+ designs. Thank you. That brings the total series lineup to nearly 400 designs in just a few short months. Now that is massive scale. Let's look at some of the capabilities of the Core Series 3, and we can start with battery life. You know, I can go over these numbers here that are printed, and I can talk about how we measure them and things like that, but I have a question for you guys. How long is your day? 10 hours? 12 hours? 14 hours? Or more, like us at Intel? But the great user experience is if your PC lasts longer than your workday. And that's exactly what we're delivering in all segments. And we support ample number of ports for all of your connectivity needs. Unlike some of our competitors who only have one USB-C interface, but I'll let you be the judge of that one. Yeah. The goal of this Core Series 3 is to bring premium feel and experiences to incredibly thin form factors for mainstream PCs. And you know, you don't have to take my word for it. You can look at this wall of incredibly designed, sleek PCs that are here, and all of it is thanks to you, our partners, and our customers. We couldn't have done it without you. So please, a round of applause. Isn't it awesome? Super light, super thin, really great. Okay, now the next proof is scaling 18A IP into growing markets. And the fastest growing portion of the PC market is the handheld gaming. Let's take a look. This is the Arc G3. I think a beautiful chip, more beautiful than what was presented yesterday at the keynote. Okay. The G3 is derived from the Core Ultra Series 3, and the Arc G3 is a tuned, high-performance GPU specifically for handheld gaming, and it's providing great battery life. The performance tested across multiple games is consistent and stable versus competition. We are more than 40% faster, 40% faster, and at the same performance, we're half the power. And on top of that, we're running all AAA games at 1080p resolution, many of them above 120 frames per second. Now that is giving gamers a great user experience. All of these devices will be available later this month, and this is just the beginning. We're going to have plenty more designs coming throughout the year. Thank you. Thank you. Okay, it is indeed true that Intel has a leading lineup of processors. And with the versatility of the 18A process technology, our newest offerings, we're bringing powerful performance and efficiency to scale across the breadth of premium, mainstream, and handheld gaming segments. These same fundamentals, the same IP, the same capabilities, can deliver far beyond the PC ecosystem. The demand for our processors at the edge has been booming. As you've seen, we've already taken existing product lines and pivoted them into adjacent markets, enabling our customers to grow their businesses. Now, the edge is demanding the latest products from Intel, and that's why this year we're taking our latest Series 3 products into the edge business with over 130 designs in multiple verticals. For large-scale edge business, our customers need the best technology and chipsets, easy-to-use reference designs, and appropriate software stacks. And at Intel, we've done all of that. We have over 4,000 edge ecosystem partners deploying into such verticals such as manufacturing, robotics, retail, and many more. For those of you here at COMPUTEX, you can see some of that at the pavilion. Given that capability, given the IP, given the chipsets, given the scale that we have, there's a massive opportunity ahead of us across many segments of physical AI. It's projected to be a $25 trillion market by 2050, and it will leverage all of our scale in the PC ecosystem. Physical AI form factors will take shape across key industries, as you see behind me. We will continue growing these markets with the same strategy of leading IP and chipsets, complete reference platforms, of end-user hardware and applicable software stacks, enabling our customers to expand into new physical AI form factors and applications. And indeed, this will be our future. Now, back to you, Lip-Bu. Thank you. Thank you. Thank you. Thank you.
Thanks, Alex. AI is profoundly impacting the way we use our devices. A major focus area for us is the use of AI on device. Together with partners, we are at the forefront of advancing intelligence. To tell you more about it, let me welcome on stage my close friend and founder, CEO of Perplexity, Aravind. Well, Aravind, welcome. You and I have been talking about hybrid compute for a while. The reason why are clear. the privacy, cost, performance. And let's talk about how to make this work.
Yeah. So in February, we launched Perplexity Computer. Computer is an AI operating system. It creates a team of agents, uses up to 20 different AI models, and it orchestrates across models, tools, and files in one single system. The agent harness inside Computer is model agnostic, perfectly balancing intelligence, accuracy, privacy, and cost is the orchestration problem it solves. And so this allows you to run smaller models locally on the Intel Core Ultra Series 3 GPU. And so for the first time ever, we worked together to create hybrid agentic inference. And so what we're showing today is just the start. Hybrid agentic inference is how we maximize token value per watt per user.
So should we show them how it works?
Yep. All right, so here it is. Let's say I'm an associate at a private equity firm, and I'm working on something that has a confidential project codenamed Project Falcon. Here's the query. So think of it as me trying to understand if a certain private company is worth $1.1 billion, and I'm feeding it confidential deal materials. The work begins on the laptop. It sees that Project Falcon has private deal room files and an NDA, a local leveraged buyout financial model, a whiteboard diagram, and bilingual transcripts that are very confidential. You don't want these materials to be shipped to the server. So what the local model does on the Core Ultra Series 3 is it first decides this is all very important work and shouldn't be sent to the server. It reads the files, classifies what is sensitive and what is not, and then Computer decides what should leave the device and what shouldn't, and each of these things is done with local AI. The orchestrator can spin up additional agents as necessary. And so if you need a research agent to bring in outside file materials against the local model without exposing any private files, that's what you want in the hybrid system. And so Computer acts as one single system, brings all inputs and outputs together. And so let's actually skip and see what the actual result would be. All right, so the result is a document, a research report, and sporting data. And it's being created by agents on large cloud-based models, keeping your sensitive information only on your device. And so all your local device models will take care of the private files, and the server-side models will take care of other things. True hybrid inference orchestration.
This is the architecture we both believe in. And the future is more compute in the data center and more compute on the local machine.
And so I think of this as a big milestone for engineering on both the agent harness AI side as well as the chip side. And so it's been really fun to partner with you and Intel on this. So thank you so much, Lip-Bu.
Definitely. Thank you, Aravind, and looking forward to continue partnership. Thank you. We talk a lot about the exciting new developments in the PC, edge, and physical AI space. I want to take a few minutes to talk about the foundational IP that power all these advancements. Let us talk about x86. When most people think of general purpose computing, they think x86. And that is a good reason for that. x86 is architecture that has powered data center for nearly 5 decades. And the leadership continues. According to the IDC, expect 8 out of the 10 servers installed through 2030 to be x86 based, powering modern computing from foundational to emerging intelligent use cases. Intel pioneered most of the breakthrough architecture innovation that have enhanced x86 over the last 4 decades, starting with the 8086 that became the foundation of modern computing. If you can see the chart. Today, we have 2 flagship CPU cores, P cores and E cores. One optimized for performance, the others is for efficiency. These are Intel's most advanced CPU cores, with the accelerator built in specifically for foundational workloads like security. Our x86 cores power our PC, client, edge portfolio, and also power our data center and AI portfolio. Under my leadership, we are committed to building the best CPU cores in the world. And we will ensure that the most compute-intensive workload run best on x86. Next, let us talk. Thank you. Now let us talk about how x86 is enabling foundational data centers. To tell you more about it, let me invite onto the stage Kavok.
Thank you. Thank you. Thank you, Lip-Bu. Wow, it's so great to be here. Specifically in this point in our history, global history, collective history, and be at COMPUTEX with the blue badge. So I'm very happy, I'm very humbled to be here to share with you some of the innovations that we have. So let's talk a bit about, see what this AI thing is about. So when we say foundational, we mean the workloads that keep the world running. So currently we have data centers, and there's a number of items and workloads and entities that run on these data centers. So, for example, we have 5G networks that keep us connected. We have databases that keep our data safe. We have cloud services that power our daily lives. So we expect and demand for these workloads to grow in size and capacity between now and 2030 from 80 gigawatts to about 100 gigawatts. And yeah, most of you involved in this domain understand the extent of this type of an expansion. These workloads are broad, they are mission critical, so special attention has to be taken when running them. But also they require performance, efficiency, security, and resiliency. And we can't emphasize enough all these 4 factors. That is why we are excited to have Intel Xeon 6 Plus introduced at COMPUTEX this week. It has 288 E-cores, a massive 576 megabytes of L3 cache, built with our Intel 18A technology. And we can't emphasize enough the value of Intel technology that brings to data center products. But most importantly, it delivers efficiency and density, which enables our partners to save very precious real estate, have more compact servers and the racks. So this is a leadership compute for the next era of cloud and network infrastructure. So Xeon 6 Plus launches with the strength of our ecosystem that's been built over decades and decades of data center development, both from a hardware, but also from a software and infrastructure perspective. Moreover, our ODM partners are bringing Xeon 6+ solutions to the market today. So these range from full rack scale deployments to server level designs. Xeon 6+ joins our lineup of data center processors next to our already launched Xeon 6 based on P-cores. Both of these category and class of solutions delivers new performance and choice for all the enterprises whose infrastructure backbone is built on x86 and Xeon. This is critical for enterprises that need to increasingly balance preparing for AI workloads, but at the same time running their day-to-day mission-critical applications. So let's switch gears and talk about how Intel is simplifying the deployment of intelligence at scale. It's undeniable that enterprise infrastructure today will have to evolve to keep up with the AI demand. Recent research forecasts that AI inference workloads are expected to become 40% of all data center power demand, and much more than they are today. So we have these two paradigms where we have the foundational data centers keep on running their traditional workloads, but at the same time, they have to figure out ways of building their infrastructures to serve intelligence at scale. And this is where Intel and Xeon 6+ come in. Now, up to now, training split the data center into two. So on one hand, we have CPU-led enterprise infrastructure, and the other hand, we have GPU-heavy AI factories. And that was very clear divide for a while, right? And we've all been accustomed to that reality. But as agentic AI moves into real workflows, data, tools, governance, the needs change. The next wave is not just about training models, it is about putting AI to work. So let's look at why agentic AI changes the infrastructure equation. The way AI inference works is straightforward. We take a prompt, it gets fed into an LLM, where it spends most time reasoning about the prompt. I mean, we've all seen this, we've done this thousands of times. And out comes an answer. In this case, a lot of time is spent computing the large language model, which is mostly GPU and compute intensive. Now, the way agentic AI works is radically different. It's given goals rather than prompts. So we've all seen the different types of loop that people are running on this agentic AI. It's also very iterative in nature, but also prompted by automation. And thinking, planning, acting, and reflecting are a natural way of these agents interacting with us. As it works, it uses tools, reads and writes files, checks rules, and other aspects that were in the traditional realm of CPUs and x86. And then for each step, the type of underlying compute needs is very different, and we'll show that in a bit. This is particularly important as agents scale up their work, spawning new agents that work concurrently. And the category and the complexity of agents are going to be very different depending on the complexity of the work. That's the main reason that there's such a rapid increase in CPU demand. For agentic AI, the CPU orchestrates the show. Now, what we're seeing is, we're also seeing the balance and the ratio of 1 CPU to 8 GPU and more is coming much closer to parity. So let's take a look at the real example. John?
Thanks, Kevork. You talked about how agentic AI is changing the compute requirements. Let's take a look at a real example. I have a traditional AI inference setup on the left-hand side of the screen. Let's send a request. Write a Python function that calls an OpenAI-compatible chat completions API. The model gets the response, generates code, and sends the request back. Take a look at the slider on the top of the screen. GPU dominates nearly 7-to-1 GPU heavy. In contrast, let's take a look at an agentic AI system. Across the top, look at the pipeline stages. Green is GPU work, blue is CPU work. Linting is happening on our Xeon 6 Plus processor with efficiency cores. Web fetch and compile is happening on our Xeon 6 performance cores. And unit testing is coming back and running on our Xeon 6 Plus efficiency cores. The right class CPU for each stage of the pipeline. Take a look at the slider across the top again. We're near parity, but CPU heavy this time. What's this look like when we multiply that by millions of queries a day? As you mentioned, each Xeon 6 Plus processor has up to 288 cores. That's 576 cores per 2-socket server. When we look at that from a rack scale perspective, that gives us over 36,000 cores per 32 U's of compute space.
Thank you, John. Wow, this is pretty amazing and some data to ponder on. By far, the density of CPU we showed has the highest density per rack ever. But also, looking at the number of agents, these are the new metrics that are emerging. We can safely say that that particular rack can run up to 150,000 agents. So, good news to all the CIOs in the audience. Now your very expensive GPUs can see more utilization because of our solutions. Now, both Xeon 6 with P cores and E cores are built for intelligence at scale. There are different cores, of course, but we've seen the workloads that require very high performance cores pushing the frequencies, but also there's a need for very high density power efficient cores. So we've seen all the workloads, we've run all the analysis, and we are delivering these solutions to all of you. Now, having said that, we are working with our customers and partners to make sure that each solution is tailored to your needs. So I'd like to welcome Lip-Bu back on stage to talk about the server and rack scale solutions that our partners are working on. Thank you.
Thank you, my friend.
Thank you. Thank you.
Thank you, Kavok. It is great to see the momentum in the data center. As we look forward to see that is for intelligence at scale, discrete compute alone is not enough. Our customers are asking us to think of system level to help them serve real agentic workloads at scale. It pushes us to rethink how we deliver our compute beyond the socket and to the rack. That is why we start the initiative called Rack Scale Blueprints, working with ecosystem partners to develop rack scale blueprints built on open standards, so customers can rapidly scale their intelligent infrastructure with confidence without proprietary workarounds. Behind me, as you can see, two examples of these blueprints. One is for agentic performance based on Intel Xeon 6 with P cores. The other is agent density with the Intel Xeon 6 Plus with E cores. We are working closely with our partners' ecosystem, including Foxconn, SambaNova, to expand our rack scale offering. Let me call on stage one of our partners, Chief Product Officer of Foxconn, Jerry Xiao, to talk about how we partner on rack scale solution.
Thank you, Lip-Bu.
Thank you, Jerry.
I'm so excited to be here today. Wonderful product and amazing event.
Jerry, Intel and Foxconn have been working together to many decades, and Foxconn has been instrumental in driving technology innovation in Taiwan and around the world.
Yeah, that's right, Lip-Bu. I'm proud of the work we have done together, from AI servers to data centers and to edge computing all together.
And today, we're excited to announce the next step in our partnership. Intel and Foxconn are working together to develop rack-scale products built upon Intel Xeon processors. Together, we will focus on exploring the development, integrations, and commercialization of differentiated rack-scale AI infrastructure solution, leveraging complementary architecture to address diverse AI workload requirements.
Yeah, together, we will continue to deepen and expand our partnership, unlocking new opportunities ahead. Through this collaboration, we will deliver system-level AI solutions to our joint customers, enabling more integrated and scalable computing environments. This marks an important step ahead, and we look forward to unveiling more in the near future. Thank you, Lip-Bu.
Today is an exciting milestone for our continued partnership with Foxconn. Jerry, thank you for joining us.
Fantastic. Thank you for having me, Lip-Bu.
Sure. Okay. Thank you to the many partners in the audience today that is helping to bring this rack-scale vision to life, providing choice through the ecosystem power. We do not believe one-size-fits-all approach for intelligence centers. Each enterprise will run unique workloads. So their infrastructure needs will also need to be unique and purpose-built, as you can see from the screen here. Just look at the server in front of me. This is a whole series of partnerships we have. Intel is working with a lot of partners to provide servers, rack-scale solution designed to fit your existing infrastructure ready for AI at scale, as you can tell in front of you. We see token usage exploding. Agents now consume 1,000 times more tokens than single event reasoning. In addition to building the best CPUs, it is critical that we deliver compute solutions optimized for token consumption and token generation. The bottom line, AI at scale will require heterogeneous computing. To this end, Intel recently announced a partnership with SambaNova. To talk more about this, let me call to the stage founder CEO of SambaNova, Rodrigo Leong. Rodrigo, welcome to joining me today.
Thank you, Lip-Bu.
And over the next few months, we have announced few updates on our joint development partnership. Can we talk a little bit more about the work that Intel and SambaNova are doing together?
Absolutely. We've been busy. Earlier this year, we announced a multi-year collaboration to deliver high-performance, cost-efficient AI inference solutions based on Xeon infrastructure. We've been building something really special and excited to show you today. This is the SM50 Samba rack we announced earlier this year, rack-scale AI infrastructure built for agentic workloads. It uses Intel Xeon 6 processors with SambaNova SM50 RDUs and shipping to customers later this year. Today, we're also excited to demonstrate the world's first heterogeneous disaggregated inference using SemiNova's RDU with Intel's CPU and Nvidia GPUs. What you're about to see is the same prompt, the same model running side by side, 2 different stacks. So the one on the left is GPUs, RDUs, and CPUs disaggregated inference. And this one on my right is GPUs on their own. They both get fed the same prompt in the same model, just different stacks. The disaggregated inference stack is taking off. And what's happening here is you have the Xeon 6 processors doing all the tooling execution. You have SemiNova RDUs doing the decode and generating all of the tokens. And then you've got the GPUs performing the prompt caching and the faster prefill, reducing overall time. When all 3 chips are working together, you dramatically reduce the end-to-end latency and the agents the fastest need for agentic AI. And the other side, the GPU stack is still working away. So the initial results of our work is disaggregated inference is the GPUs, the RDUs, the CPUs, that's the fastest. And artificial analysis and our tests found it to be 2 to 3 times faster than just the GPUs alone. And this gives us an early look at how fast this can be.
Rodrigo, the most exciting part about all this is that we have tremendous customer interest in these solutions.
Absolutely. So let's see who comes next. So, Lip-Bu, turn it back over to you.
Thank you so much.
Thank you. Thank you.
To continue this conversation, I'm delighted to invite my good friends. Robert Smith is Vista Equity Partners Chairman, CEO, and the partners, and Roger Smith, to tell you more about how they plan to use these racks from Intel and SemiNova. Robert?
Great, thank you. Lip-Bu, good to see you.
Same here. Thank you so much for joining me.
Pleasure.
Delighted.
Thank you, my friend. Thank you, my friend.
Yes. So, Robert, AI is driving huge demand for computing, and it is reshaping the silicon system software and all at once. What are you seeing and hearing from the enterprises that you work with?
Yeah, first of all, I'm excited to be here at COMPUTEX to join you at this wonderful event. For us, it's been quite incredible. There's been a huge focus right now to bring AI to enterprises around the globe. We want to make it usable. We want to make it impactful for the organizations that we work with. You know, we have over 90 portfolio companies, and well over half of them have now have converted to agentic solutions. And with over 750 million users of our software, that really translates to over 10 billion agents. That's why we've launched Vector Core Compute, or VC2, with our partners at Cambium Capital to offer the world's first commercially available architecture for disaggregated inference. This novel agentic neocloud is built to deliver the fastest enterprise inference throughput of any architecture to date. The demo you just witnessed with Rodrigo was conducted live in our Los Angeles data center, and we have over 50 deployments planned in the US, which are targeted to convert existing data centers to inference data centers.
This is very exciting. And as we saw from Rodrigo a few minutes ago, we are already starting to see strong momentum for these offerings. Can you talk a little bit more about how Intel, Vector Core Compute, and our partners like SemiNova are bringing this aggregated inference to life?
Of course. I'm excited to share that First Together AI is the first commercial customer and is excited to use this architecture as a service to accelerate inference workloads. We expect many of our enterprise software companies and their customers to quickly follow as the demands for inference keep growing, and it is more efficient than anything they previously have had access to. Most critically, VC2 is built and utilizes the SemiNova stack, which is an air-cooled data center. We believe it will deliver what enterprise customers and communities are asking for, which is reliable, low latency, low cost inference at scale. Partnering to advance AI is one of the best ways to develop this transformational technology, making it usable and economically viable for enterprises worldwide.
We are excited about that. Thank you for joining me today, and delighted to have you here.
Always a pleasure, Lip-Bu. Thank you. Congratulations. 14 more months. We're excited to see what you're doing.
Thank you.
Thank you.
As you just saw from Rodrigo and Robert, picking the right silicon architecture for your needs is critical. For enterprises today, there's a broad range of architectures to choose from. As large workloads increasingly become strategic assets for companies, they are increasingly looking for silicon built around their exact needs. Next, I would like to invite Srini, a semiconductor design veteran and a leader of our purpose-built silicon team, to talk more about the work we are doing in this area. Srini.
Hi, Lip-Bu. Thank you. Thank you so much. A very good afternoon to you guys. Purpose-built silicon it is. This has been a journey that the industry has been using almost for the last decade or so, and especially the hyperscalers have tapped into this to its full potential and shown us the benefits in every way possible. Lip-Bu, last year you challenged us to see, in this space, given the fantastic assets and the breadth of assets that we have at Intel, how could we be relevant to this? Not just be focused on the stuff that we do internally, how do we bring this out to the external world and do something more? With that said, we had a proposition, we've been working on it, and today I'm very happy to share a couple of good outcomes that we have. The first, on the hyperscaler side, we have Google and Intel, or Google and Intel have gone into a partnership wherein Intel is delivering what is called as the infrastructure processing unit. I would call it Intel processing unit, actually. But infrastructure processing unit, which is a piece of silicon very vital for hyperscalers' performance, and that journey continues. And by the way, this is a deployment today, so it is not just something that we are doing, but it's already designed and being deployed. While this is working on, Intel as a company has been pretty active in the telco market, and in this telco market, another marquee customer, Ericsson, has been partnering with us, and Ericsson chooses us wherein we deliver, or Intel delivers, the next generation infrastructure silicon at a global scale for them across the board. This just gives you a very sneak preview at the highest level to see the kind of work that's happening in the purpose-built silicon space, which is a very exciting space, and more importantly, a high growth space. And I was just thinking, what better place than COMPUTEX and Taipei, where custom silicon really is the name of the game here, to announce that Intel has officially entered this market. So looking forward to working with many of you guys and see how we can be relevant to you, some of your aspirational goals on silicon. Okay? Thank you, Lip-Bu.
I'm super excited about all these partnerships that you announced, and more to come.
Yes, so, absolutely more to come. Yes,
thank
Lip-Bu.
you so much.
Thank you so much, Lip-Bu. Thank you.
Thank you. The work Srini and the team are doing with purpose-built silicon is really important. I'm super excited to be partnering to build custom silicon with many leading-edge companies, as well as some of the most dynamic startups across the industry vertical. I would like to highlight some of this partnership today. One of the most exciting areas where we can deploy advanced silicon is biomedical engineering. For years, emulating the functionality of the human brain has been the holy grail of computing. One company that is in the forefront of brain-inspired computing is Echo Neurotechnologies. Let us hear more from Eddie Chen, founder CEO of Echo Neurotechnology, and also one of the world's best neurosurgeons.
Hi, I'm Eddie Chang. I'm a neurosurgeon at UCSF and co-founder of Echo Neurotechnologies. For decades, AI has been brain-inspired, meaning borrowing ideas from neuroscience at a distance. Neuromorphic computing has carried that vision the furthest. It builds silicon around the brain's core principles like spikes, sparse, communication, memory, and compute, all in the same place. That architecture is right, but what's been missing is direct evidence of how the brain actually performs the computation. That's now within our reach. For the first time, we can study how the human cortex computes language in real time, at the resolution where computation actually happens. This opens a whole new possibility. Algorithms that are not just brain-inspired, but new ones that are trained on the brain activity itself, measured against the brain itself. That's the shift in our collaboration with Intel. Together, we're developing brain-trained algorithms for streaming speech that approach the efficiency of biological computation. The payoff runs both ways: AI that's faster, lighter, and closer to how we actually think, and new tools to restore speech to people who have lost it. Together with Intel, we're building AI that learns from the most powerful computer ever discovered, the human brain. We're excited about what's ahead. Thank you.
Thank you, Eddie. I'm amazed by the work you are doing. I'm confident that our work together will help lay the foundation of highly efficient AI computers in the future. Another company doing work at the cutting edge of biology is Greenstone Technologies. We are partnering with Greenstone to establish scalable reference architectures applicable across the broader life science imaging ecosystem. Dr. Joseph Wu is the head of cardiology at Stanford and the founder CEO of Greenstone. Let's hear from him.
Hello, my name is Joseph Wu, and I'm a professor of medicine and director of the Stanford Cardiovascular Institute, as well as the co-founder of Greenstone Biosciences. Thank you so much for including me in COMPUTEX. Intel and Greenstone are working together to speed up the development of new medicines. Our partnership combines state-of-the-art human genetics and biology from Greenstone with advanced AI computing from Intel so that we can scale data processing, storage, and analysis. Greenstone has built the world's largest biobank of human-induced pluripotent stem cells. From just 10 cc's of your blood, we can make your brain, heart, liver, kidney, gut, and any type of organoids in your body that are genetically identical to the patient. This will then allow us to test existing and new medications more quickly and at a lower cost. I believe the combination of human biology and AI computing will help shape the future of biomedicines in the next decade. And this is why we're so excited about the partnership between Intel and Greenstone Biosciences. Thank you very much and enjoy the event. 谢谢大家.
Thank you, Joe. I'm amazed by the work you are doing, and I'm excited about the potential of our partnership. Another key partner is Hitachi. They have a wide range of capabilities that help accelerating our work, our plan around foundry tools and quantum computing system. Let us hear from Hitachi CEO, Tokunaga-san.
Hello, COMPUTEX. I'm Toshiaki Tokunaga, CEO of Hitachi. For decades, Hitachi and Intel have worked together to solve key challenges for society. And today, we are bringing our strength even closer. By combining Intel's advanced computing with Hitachi's industrial strength in the physical world, we will create intelligent solutions that will benefit both businesses and society. Thank you, Lip-Bu. I look forward to our future together.
Thank you, TT. We are really looking forward to working with you. Finally, if you look at, we have the brains-inspired computing, biomedical, medicine, and then energy. The last one is industrial automation. Finally, one partner I would like you to hear from is known for their pioneering work in industrial automation. Let us hear from my very good friend, Roland Busch at Siemens.
Hi, Lip-Bu. As a customer of Intel, we all know that global semiconductor demand has hit a high record. In 2023, Siemens and Intel already joined forces to meet it. And now we are taking our collaboration to the next level. We are expanding our partnership across the entire value chain, from design to manufacturing to chip applications in Siemens products. We improve design quality through EDA automation and software solutions built with agentic AI. We partner on all areas of the manufacturing process, including product lifecycle management, automation, electrification, quality, and sustainability. And what makes this even more relevant for us, the chips created in this value chain will be used in our own Siemens products. Looking forward to what's coming up.
Thank you, Roland. We are delighted to expand our long partnership with the Siemens groups. I'm looking forward to disclose more about this partnership in the coming months. And we are working with several other partners to keep pushing the boundary of what is possible. I would like to close by returning to where we start our conversation. The opportunity for Intel and for our partners is immense. PC, edge, agentic, physical AI, data center, and emerging intelligence center. From silicon to SoC to system and applications. This opportunity is only made possible by all of you. Look at the list. And the largest ecosystem of partners, suppliers, and customers. Intel is an iconic company. We laid the foundation of modern-day computing. And we are proud of our heritage. But we do not want to rest on our honors and glory. A year ago, I joined as a CEO. I challenged my team to work with me to build a new Intel. That is exactly what we are doing. We are not encumbered by the past. We are building something wonderful. It has been a year of transformation for Intel. We ramped our 18A to high volume with multiple products. We are executing well on our advanced packaging milestones. We make tremendous progress on engaging customers and building our foundry business. We introduce new SoCs for all major compute platforms, from premium mobile to high-density cloud and 5G. We are rebuilding and strengthening partnership across the ecosystem. We are double down on creating new business opportunity across existing and emerging domains. We are working at the forefront to reimagine computing and make it highly efficient for the AI era. And this is just the beginning. I'm super excited to continue executing at hyper speed.
Before the lights go out, the race begins. Performance begins with compute, with electrons that power pace, and data that backs decisions. The race never ends. Engineering never stops. Intel, official compute partner of McLaren Racing.
Ladies and gentlemen, this concludes the Intel COMPUTEX 2026 keynote. Thank you for joining us this afternoon to witness the future of technology. We look forward to seeing you again at future Intel events. And please don't forget your personal belongings.